So in today's class we are going to discuss about cohesion and coupling, as I have told you previously in our previous class. Now what is cohesion and coupling? Let us do a small review of what was cohesion and coupling. So first of all, what was cohesion? Cohesion was when we are having a particular program. Okay, so in that program we are having some modules. As I have already told you about system, subsystem and modules in between those subsystems. Now what is that? This is my module, that is my module 1, and this is my module 2, M2. Okay, now what is this? What is cohesion? In case of cohesion, what we know is the interdependability or the intercommunication, the interrelation, whatever you want to say, that is how these two are dependent. Okay, this is called coupling, and these have some elements. This particular module have some elements in between them. This also, here also. Okay, so these modules or these elements, they are also having some interconnection between them. That is the interdependability of these elements in a particular module, that is known as cohesion. Then, and the interdependability between these two particular modules, okay, that is known as coupling. Clear? What is cohesion? Cohesion is the interdependability between elements of a particular module, and coupling is the interdependability between two particular modules. Okay, this is the difference between cohesion and coupling. Now, if for a particular program, what should be the cohesion and what should be the coupling? Okay, the cohesion should be always high. Higher the cohesion, your program will be better, and the coupling should be low. Okay, that is, for a program design we see that the cohesion should be higher and the coupling should be lower. This is the main logic between a cohesion and coupling. Now when we are discussing about cohesion, that is how the particular elements in a particular module, how they are interdependent on each other, how they are communicating with each other. So for that we have 7 kinds of cohesion. Okay, 7 kinds of cohesion are there, by which we can see how the different elements are, how they are interlinked with each other in a particular module. Then, so let's first start with coincidental cohesion. What is coincidental cohesion? That is unplanned and random. Since this kind of cohesion is totally unplanned, it is unaccepted. As we know, when we are going on with some unplanned feature, that is, it is unaccepted, because it generally, what it happens, it just creates some kinds of problems, or it may create some kinds of unstructured thing. Okay, that's why, since this is random, unplanned and random, we are just taking some random interconnection between these particular elements of the module, as well as breaking the program into several modules. There is no particular number in which we are going to break the elements of our module. So this is as it is unplanned as well as it is random. So there may be many number of particular elements inside a module. So obviously it is unaccepted. It creates some chaos in the with the programmers. So this kind of cohesion is generally unaccepted in our program design. So this is what is our coincidental cohesion. This is the first kind of cohesion in our cohesion types. Okay. Now second type of cohesion, that is our logical cohesion. What is logical cohesion? When logically categorized elements are put together in a particular module. Suppose this is our module. Okay, this is our M1, this is module. So when in a particular M1 module, all the elements which are there, suppose this is E1, E2, E3, these should be logically connected. These should be logically same here. Okay, when logically categorized elements, when we are categorizing the elements logically, they should be same. So in that case they are put together in a module. Okay, so this kind of cohesion is known as logical cohesion. Then, so this is our second kind of cohesion, that is logical cohesion. Now, what is our third kind of cohesion? Third kind of cohesion is, this is temporal cohesion. What is temporal cohesion? When elements of a module are organized in such a way that they are processed at a similar point of time. Okay, what that means? Suppose this is our module M1 and this is our elements E1, E2, E3, E4, etc., etc. Okay, so this here what happens, elements processed at a similar point of time. Suppose when there are many elements in your module, particular module, maybe those elements, they are not processed in the same time. Okay, different elements are grouped together, and those elements maybe they are processed at a similar time or maybe at another time. So those elements which are processed at the same point of time, those elements are grouped here and they are known as temporal cohesion. The interdependability between those elements which are processed at the same time, that is called temporal cohesion. That means at the same instant of time. They are all executed at the same instant of time. They are grouped together. That grouping or that the interconnection between those kind of particular elements in a particular module, that is our temporal cohesion. Then fourth one is our procedural cohesion. What is procedural cohesion? Here elements grouped together to perform a similar task. That was what in temporal cohesion? They were executed at a similar point of time. Now we are talking about what? Again we are having a module M1 and this particular E1, E2, E3, E4. Here what we will see? Those elements that are grouped together which are performing the similar task. Suppose here if E1, E2 and E4, they are performing some task and they are performing another task. So the interdependability between these two and these two, they are grouped together. They are grouped individually, they are grouped individually. So the interdependability between those particular elements in a module which are doing the similar kind of task. Okay, same task, they are performing the same task. So those kind of elements, they are grouped together in a module. Different elements are there. They are working at different time. They are working they are doing different tasks. Okay, so first one in temporal, what we were seeing about the same time, same point of time. Now we are seeing what? Same kind of task, doing same kind of task. So those particular interdependability between those elements in a module which are performing similar kind of task, that is known as procedural cohesion. Okay, that is our fourth kind of cohesion. Then now our fifth kind of cohesion. What is that? Communicational cohesion. Now what is communicational cohesion? Elements executed sequentially work on same data or info. Now what happens here? Okay, one more thing, that is in procedural cohesion. Here we have to see one thing. This kind of particular, we have to see what they have to be done in sequential order. They are in structured type. Okay, these elements which are grouped if perform a similar task, that is we have to see they should be in a sequential order. Okay, here also we have to see that elements executed sequentially work on same data or info. Maybe their work are different, as we have seen there in temporal, same instant of time, in procedural, same work, same function. Now what? Now we have to see what? That maybe their function are different, but they are working on the same data or information. Then maybe their work are different. Suppose this E1, E2, they are inside a module M1. Okay, E3, E4. Maybe these two are working on, they are doing another task, and they are doing T1, they are doing T2. Different tasks. But what thing we have to see here? Not the task. What task they are performing? Same task that was in our procedural cohesion. Now what we have to see? Maybe their tasks are different, but we have to see they are working on the same data set, that is D1. Clear? We have to see what? we have to see that if they are working, they are doing the same task, then that is our procedural cohesion. But here maybe the tasks are different, maybe they are doing different tasks, but they are working on the same data. Someone is inserting the data, someone is deleting the data, but working on the same type of data. That is our communicational cohesion. Here what? First, same time, temporal, same task, now same data. But other features can be different. When you are talking about the same time, it is working on same time, at the same time the execution is going on. But maybe the work is different, maybe the data set is different, that can be there. Same thing when it is happening here, same work is done, maybe the time may be different, execution time or the data set may be different. When the same data set they are working on, time or the other features can be different. But you have to see the same data set, they are working on the same data set. So this is our fifth kind of cohesion. Then now our sixth kind of cohesion, that is our sequential cohesion. Now what is sequential cohesion? This is the most important type of cohesion. That is, here suppose in our module M1, here what is happening? Here we have to see the sequential or the sequence of the elements of our cohesion. What is the sequence? Suppose this is my E1, this is the element, this is E2 and so on En. Now what we have to see here, output of one element should be input to the another element here. Now what? This is my E1, this is having some input and some output. Now I have to see that these output should be input of E2. E1's output should be input of E2. Then again here this output O2 should be input of, here if E3 is there, I3. So here we have to see the sequence of our input output. The input of one element, if we are working on two elements, we have to see the input of one element should be the output of another element. So it will be in a sequential logic. Then this kind of cohesion is known as sequential cohesion. It is easy. That sequential cohesion means the input of this particular element should be the output of another element. So this is what is called our sequential cohesion. Then here no instant of time or logic or data or anything, we are not describing about that one. Here only one thing we are seeing, the input of one element should be the output of next element. This sequence should be maintained. Those kind of elements which are maintaining this kind of sequence in your particular module, those particular elements, the interdependability between those particular elements which are performing in this sequential logic, that is they are grouped in our this sequential cohesion. Then our seventh one, all elements contribute single well-defined function. Here what we have to see, when we are defining a particular function, as we have seen there all the high level function f1, suppose it is there, e1, e2, e3, e4, if some other elements are there. So here what we have to see, this is the highest degree of cohesion. Okay, this is highly accepted also. So these elements in a module, that is functional cohesion, should be grouped in such a way that they are contribute to a single well-defined function. Suppose this is your single well-defined function. So these elements, all of these elements should contribute to this particular function f1. As we have seen in our library management system, f1 was a high level function. We were searching the book for about our author's name. Then it was defining how it was giving us the rack number and other things. The processing was done. So a single defined function is there. All the elements of this particular module should contribute to that single well-defined function. If they are contributing, they should be grouped together and they are given in a particular group, that is functional cohesion. This is the highest level of our cohesion. This functional cohesion is the highest level of our cohesion. Why? Since this is working on a single function. Processing is done, we have seen there also, when the processing was done, that was done on a basis of a high level function. Also here that is going on. That is, your high level, your all are contributing to a single well-defined function. When they are talking about a function, obviously it is a structured manner. It is well planned. It's not unplanned. Obviously, this is accepted. This is expected as well as this is accepted. Okay, this is the accepted one. That is our high level. This is the highest level. Functional cohesion is the highest level of cohesion. Done. And this was the lowest level of cohesion. That is our coincidental cohesion. And since it was unplanned, it is not accepted. Okay, this kind of cohesion is not accepted since it was unplanned. So what we see from coincidental to functional, what we are seeing, this is going on increasing in increasing level. This is the highest level, the 7th one. And what? This was unplanned, and going through this we are seeing the highest level, that is the planned and structured cohesion. Here all the elements, they are dependent on each other, and they are highly attached with each other. Okay, so as we have already told, highest cohesion, that is high the cohesion, best is your program. So functional cohesion is the highly accepted one. Done. Now we will be talking about our coupling. Done. What is coupling? Cohesion was the interdependability between the elements of a particular module. Now we will see how the interdependability between the different modules are described. Okay, so let's see now what is happening in a coupling. So first, coupling are also of 5 types. Okay, but mainly there is no such coupling which is highly accepted or another thing. So coupling are mainly of 5 types, but not any coupling means ideally they are not accepted. No coupling is ideally best. No coupling is there. Every coupling can be used and they are equally standard. That is not ideally, that we have seen in cohesion that functional cohesion is the ideal one, or it is the best accepted one. But in coupling, no such case is there. Okay, now let's see first coupling, that is our content coupling. Then here what? Directly access or modify content of another module. That is when in a module they are directly accept or maybe they can refer to content of another module. Suppose this is my module 1 and this is my module 2. Done. Then what we will see, how the dependability will be accessed or seen or checked. First thing is, they can directly access, these can directly access this can directly access this, the data of each other. Then second, what? They can modify, they can directly access. First of all, they can directly access each other. Okay. Second, they can directly modify, or they can modify each other. Okay. Suppose some data is there D1, some data is there D2. So these can easily modify the data of module 1 and these can easily modify the data of module 2. Then third one is, they can refer to each other's data. They can refer to each other. So these kind of thing, mainly what we are seeing here, what they are doing, what they are modifying, what they are referring to. Mainly they are referring, they are modifying, or they are directly accessing what? The content of each other. What they are accessing? They are accessing the data, that is the content which is in between the modules. That is the thing. So here what we are seeing, the content in this particular, that is C1, here C2, this is the content of our module 1 and 2. So what is happening there, how we are accessing or how we are checking the interdependability, that is they can directly access each other's content. M1 can access C2, that is content of M2. Okay, and this is the content of M1. So what is happening there? M1 can access the content of M2, can modify the content of M2, okay, and can refer to the content of M2 in case of reference. And M2 can also, it can directly access the content of M1, that is our C1, modify, it can also modify the content of our M1 and refer to the content of M1. So when we are talking about the content of M1 and M2, and on the basis of the modification, reference or access of these particular contents, this kind of coupling or this kind of interrelation or interdependability is known as content coupling. This is the first kind of coupling of our coupling types. Then, clear? Now, let's see the next kind of coupling which comes to our coupling types. Okay. Next is common coupling. Common coupling. Now, what is common coupling? Read, write, access to some global data. Here, what is happening? Here, multiple modules can, what they can do, suppose multiple modules are there, M1, M2, M3, Mn, whatever. So, what we have to see, suppose here is a common data, global data. This is my global data. Suppose D1. So, what we have to see, how we will check the interdependability between each other? We have to see they can read, write, access some global data. A common data should be there, which they can easily read. First of all, they can read, they can write, as well as they can access this data, this global data. That is my common data. I have a data, and that data can be accessed, can be read, can be write or written by these all modules. So those modules which are mainly accessing, writing, reading, whatever on a basic data, on a particular global data, that data, that common feature, that is known as our common coupling. Clear? Common data is there which has been accessed, which has been written or read by these all modules. These modules are grouped together. The interdependability between these are judged by this. This is known as this common coupling. Then, now let's see the third kind of coupling, that is our control coupling. Okay. Now, what is control coupling? Third type, that is control coupling. What is control coupling? Here, when we are talking about two modules, this is my module 1, this is my module 2. One module decides or changes the execution of the other module. Here, what is happening? One module that decides, what decides? Suppose this or this, either this or this, any module. Suppose M1, first thing what? It can decide the function of M2. Suppose M1 can decide the function of M2, or maybe vice versa. Okay. Then second what? It can change the execution of M2 or vice versa. Then, so here what we have to see, 2 points. Mainly when we are having two particular modules, what we have to see, first module, what is the name of the coupling? Control coupling. Control means it can take the control of the decisions of the other module. Clear? Very simple. It can take the decision, that is, it can decide the function here or here. Maybe M1 can decide the function of M2, or maybe M2 can decide the function of M1. Second what? Change the execution. Whatever execution is being done to M1 or M2, each other they can, what they can do, they can change the execution of the other one. So this kind of coupling is known as our control coupling, where the control of one module is taken by the another module. So this kind of interdependability is known as controlled coupling. this kind of relation, this kind of coupling is called control coupling, where the control of one module is been taken by the other module. Clear? Now we will go to our fourth kind of coupling. Mainly in coupling you can easily see whatever the name of the coupling is, mainly in 1, 2, 3 they are suggesting what is the function of the coupling. Now in fourth coupling, that is our stamped coupling. Okay, here what we are doing, share common data structure and but work on different thing. That is, they are sharing, suppose M1 and M2 are there, they are sharing the same data structure, sharing same data structure. Okay, their data structure are same. Whatever data they are doing and their data structure is same. Okay, but what thing is different? Different is what? They are working on different parts of the data. Okay, different parts of data. Okay, what is going on? They are working on different parts of the data. Okay, data structure is this. The structure of both the modules are same, but what is happening there? They are working on the different parts. Maybe suppose I have a data, global data again. Here one data is there. So if one particular module, it is working on some part of the data, suppose here, but M2 will be working on the different part of the data. Someone is working on the execution, or someone is working on the input output of the particular. One is working on the processing, so one is working on the input and output functions of the particular data. So this kind of thing where the same thing, same data structure is being shared between each other. They are sharing the same data structure. The structure of both the modules are, data structure of the modules are same, but they are working, their task is different. They are working on the same data also, but their task is they are working on different parts of the particular data. Done. So this kind of thing is known as stamped coupling. Okay, here the name doesn't suggest the function of the particular coupling as the previous were going on, but stamped, mainly what is happening here, they are having the same data structure but working on the different parts of the particular data. Okay, now what? The fifth one, that is our data coupling. Okay, now what is happening in data coupling? That is our fifth one, data coupling. Here what happens, all the modules, they are interacting with each other on the basis of data. How? Here all the modules, suppose M1, M2, M3, these all modules, they are interacting with each other by passing parameters. Okay, which is called our data, for our data coupling. They are how they are working? They are passing different data structure, that is they are passing the data parameters to each other. By this, interconnection is being built between these different modules. So these kind of modules where they are working on whatever its execution is done, that is done on the basis of passing parameters or passing data, different data. So this passing of data from one module to another module, this kind of interrelation or interaction between different modules is known as data coupling. Then where it is working on the data, working on passing parameters. So passing different data, that is called our data coupling. Clear? So here what we have discussed, that there are 7 kinds of cohesion and 5 kinds of coupling is there. But the main thing, what is there? The cohesion should be always high and the coupling should be low. In cohesion, what we have seen, that functional cohesion is the highly accepted one. But in coupling, no such thing is there. No such ideal coupling is there. All the coupling, they are working on the same basis, but not on means working on different, but they are ideally equally ideal. Okay, nothing is better or this is worse, nothing is like that. But in cohesion, that is there. That is, first one was coincidental cohesion, that was lowest cohesion, that was unplanned. But in our functional cohesion, that's the highest degree cohesion, highly accepted as well as expected. Clear? Now we will see, we will see about design verification. Okay, now we will see about design verification. This is what is happening in our designing phase. As we have seen what is previous classes also, what was in designing phase, different designs, levels of designing. Now we have to see that what is our design verification, how we can verify our design verification. So how you can verify anything, how you can verify that whether your program is correct or not, whether anything, to check anything, what we have to see, the output of the particular thing. Then here also we will see, we will verify this by the output of the design, Now after designing phase, what things are coming to you? What are the outputs of a designing phase? What are coming to you after doing this designing phase? What things are coming? First one is design documentation. Okay, what we have got after our requirement analysis and specification, SRS document. That was our document of the system requirements and specification. Correct? Now after designing phase, we will go to the coding phase. So in designing phase, what is our output? That is, first one is what we are getting after the designing phase. There we were getting SRS document, here we are getting the design documentation. Here it's the design documentation which is you are getting after you are doing your designing work is been done. Second one, what is that? Is pseudo codes. Some pseudo codes are there. Some codes you are getting. The whole codes, pseudo codes means some basic codes you are getting. These are not the main codes. Main codes you will get after you have done crossed your coding phase. Now you are getting some pseudo codes. That this kind of things we are going to use for our coding phase. Third one is the detailed logic. The detailed logic. Since after requirement analysis and verification, what we were getting? We were getting that what were our requirements, basic requirements which were there, which were given by the customer. Mainly a category of what kind of requirements were there, we were getting after requirement analysis and specification. But here what we are getting? Here we are getting a detailed logic now. Since you have designed your whole software, now you have the logic. There you have only the requirements gathered. Now you have the whole structure of the detailed design, whatever you are going to do in the, how you are going to code or how you are going to test your data. Correct? Now what is the fourth one? That is a process diagram. Processed diagram of, that is the mainly we will see in other classes. DFD, ERD is there. Entity relationship diagram, that data flow diagram. These things are going to be in the, so these are process diagrams are there. That how your relationship is going on. Relationship between different entities. There are entities, relationship between them, their attributes, many things are there. We will discuss that afterwards. But these things are mainly some pictorial data. Also we have seen the decision tree, decision table, that is also you have seen in here. So these kind of things you are getting, what you are getting? You are getting a diagrammatic form, in a diagrammatic form. So some process diagrams are with you, which will be helping you. And the fifth one is our functional and non-functional requirements. Okay, functional and non-functional requirements. This was also what after your SRS document was done. But now, according to after when you have the detailed design, whatever the functional requirements or non-functional requirements was there, that will be updated. You are having a fresh details about your functional and non-functional requirements. Then since your designing phase will give you these 4 different kinds of things, which will obviously change or update the requirements, that is your functional and non-functional requirements. So these are the things, these are the outputs which you are getting after you have completed your designing phase. Done. So what we have to see, you can easily verify your design. You can easily verify your design. See, after we have seen in our SDLC model also that some models were there where after designing, like in prototyping model, what we were doing, we were designing the prototype, we were giving that to the customer. The customer was giving his suggestions or feedback to you, whether he's accepting or maybe he wants some updation in your prototype. So that kind of thing, that is in your designing phase, how your designing is going to be verified. So your designing is basically going to verify how you are just giving the design, what we were giving to the customer in case of designing. So these are the things which you are going to give to your customer. Now it is cleared in this class. Okay, when you have completed your designing phase. So after completion, these things are what you are going to give to the customer, or you are going to verify by your development team that if my design is verified, my design is correct or not. These are the parameters, or these are the output of your designing phase which will verify your design whether it is correct or not. Clear? Now next phase, implementation, depends upon the outputs mentioned above. Now next phase is your implementation phase. Done. So in implementation phase, these things, these parameters will be checked. These parameters, this output will show that whether your designing is verified, whether your designing is correct or not. That now what things we have to, we know that these are the parameters. Now what things we have to keep in our mind to verify our design. You have got your outputs of your designing phase, you are ready to verify that one. But what thing you have to keep in your mind before verifying your designing phase? How you will verify? You have the parameters, done. But how you will verify? Let's see. Now how we will verify our designing phase. So there are some points which you have to keep in your mind. Okay. First one, you have to verify the output. Verify the output before next phase. What is our next phase? Next phase is our implementation phase. That is implementation phase. So what we have to do before we go to the implementation phase, you have to verify these outputs for any kind of error or anything. You have to verify your output before going to the implementation phase. This is first point which you have to keep in your mind before doing the verification. Verification should be done before the implementation phase. Second thing, better to, that is, it is better to find any errors or any faults, etc., errors or faults before the testing phase. Okay, before the testing phase. Since in not, that is not after the testing phase. Here you have to see what, when you are going for the testing phase, you should have, you are going to have the implementation, that is your coding phase. So you have to see before the testing phase, you have to clarify all kinds of error or faults if present in your designing phase. That is also being checked before the testing phase. Okay, since testing phase, obviously if some error is there, fault is there, again you have to start from the previous phase. So in case of waterfall model, we have seen that classical waterfall model, that particular thing is not present. You cannot, you don't have any feedback loop. So here what you have to see, you have to see all, check all kinds of error or anything that you have to check before your testing phase. That clear? Now third one is that is structured verification approach should be done. That is structured verification approach, okay, should be adopted. These should be adopted. That is, your verification should be any kind of mistakes or any things that can be previously whatever mistakes were there, that can be easily corrected or easily verified here. So some structured kind of verification should be done. Structured verification approach should be taken, so that any mistake or anything that should be easily cleared before your testing phase. That will be better for your programming team also. Development team is doing this one, as well as programming team will be doing your coding phase. So it will be better for both of them if some structured kind of thing is done. That's we have seen in SRS document. What was there? Some structured documentation was done. Here you have to verify that thing for the designing phase, should be verified in a structured manner also. Then third one is a good design should be reviewed. Okay, so that will be accurately. Review should be review of good design, okay, should be done accurately and correctly. Okay, accurately and correctly. Your design should be seen accurately and correctly. For what? For what thing? Your design should be mainly seen accurately and correctly for quality. Okay, quality of your design. Quality of your design. That is, the quality of whatever your design is done, that should be correct, that should be good, so that your software designing is good. Then that should be perfectly, accurately and correctly checked. Okay, if some errors, mistakes comes after this phase, then what you have to do? You have to again start a refresh. Okay, refresh start, you have to do that there. So here what we have to see, that correctly and accurately we should check for the mistakes, check for the errors, so that we can give a quality product to our customer. This designing will depend, or this designing phase will, this will only show how you are going to make your particular designing. This is the particular software. Then you are going for the coding testing. There nobody is going to verify that one. Here it is the first step. Designing is the first step of your SDLC processes of the development. That is the solution domain. So here whatever thing you have to do here only. Then so that your process, your software can be a good one, a better one. This is the main level where you have to see that thing. Okay. Then so these are the main things which are going to be in a whole designing phase of our SDLC model. Now in next class we will go for some other topics. Then if you have any queries related to the software designing, then please you can write to the comment section. I will give you the responses. Okay, and if you like my channel, please give some like and subscribe my channel. Thank you.